Hi, Ibrahim Abdullah. Ibrahim, why is the camera off?
I don't know.
You don't know? Really? You want to know why is it off?
Yes.
Okay, because you didn't click on your camera button, you just click on it, it will turn on.
Okay.
Try it.
Yeah, actually, I've been having problems with it. Can you see me?
I can see your name only, Daphne Bozkurt.
Yes.
I cannot see your face, Daphne.
This has been happening to me again.
Okay.
I'll try to do something.
Okay, try to do something. I will be back in a minute, okay? Let me just bring a glass of water and we will start. Okay, Musa, how are you?
I am fine. How about you?
I'm okay. So did you go to school today?
No, tomorrow. I will go to
Tomorrow.
school tomorrow.
Okay, good. You are back to school, but here again they have some new cases and again they close all the schools for 2 weeks starting from tomorrow. Now again I need to teach everything online. Unfortunately, what can we do? Now the situation is unstable, I think, in every part of the world. So Ibrahim, still you didn't click on your camera button. What happened?
Yes. Not working.
All right. So uh, Defna, are you still there or?
I am still here. I'm just trying to figure something out.
Okay, good. So last time we did these questions and the 3 questions left. Okay, let's finish them. And there's one challenging question for you today. Okay, that's the last question we did. All right. And find the last 3 digits of 2525. All right. Here, 25 to the power of 25, if you just actually multiply this, it says the last 3 digits. What is 25 to the power of 1? The last digit is, what is it? 25. And 25 squared, that's equal to 625. It says the last 3 digits, right? Again, 25 cubed, 25 cubed, actually that is equal to 15,625. And again, because of this 5, right, you're just multiplying this 5 by 25, it always ends with 625. Again, 25 to the power of 4, 25 to the power of 4. Again, the last digits will be something. 25 to the power of 4, something, it is 625. Okay, so the last 3 digits of powers of 25 is always end with 625, 625, 625. So that means that the last 3 digits of 25 to the power of 25 will be 625. Okay, and how do we know that? Just doing some simple observation. Okay, 25, we know that. 25 squared to 625, we know that. If you multiply by again by some 5, it will be, what is it? 625, 625, 625. Anyway, so uh, how about another question? Last time we did a similar one. Okay, we do another similar question here. Find the remainder when 3 to the power of 2014 is divided by 5. Okay, and we know that again here 3 to the power of 1. If you divide by 5, remainder is 3, right? Because why? I can write 3 is equal to 5 times 0 plus 3. So this is the remainder. And how about 3 squared? We can write it as a remainder is 4 because here 3 squared is 9. I can write it as 5 times 1 plus 4. Yeah, I have already taught 2 hours now. My eyes a bit tired. Let's put on the glasses. Okay. And how about 3 cubed? That is 27 divided by 5. It is 2, right? Because 3 cubed means 27. I can write it as 5 times 5 plus 2. All right. And how about 3 to the power of 4? We know that 3 to the power of 4 is 81. If you divide by 5, actually the remainder is 1. Because let me write here 3 to the power of 4, which is equal to 81. I can write it as 5 times 16 plus 1. All right. And that's it. Now I should stop because I was looking for the remainder. What is equal to 1? And now, right, last time, if you remember, Musa, Ibrahim, Daphne, if you're given any two whole numbers, right, a to plus b to the power of n, right? And if you remember, we can always write it as a times some natural number n or positive integer, and let's say plus b to the power of n. What does it mean? It means that if you divide this a plus b to the power of n by some number a, the remainder will be b to the power of n. At least I'm just making this number a bit smaller. Now again, I will just tell this. How about if I divide b to the power of n by that number? Because especially if this b is like small number, 1 or 2 or 3, it's easy. Again, I can just see if I divide this number by 5, what happens here. So using this, now this 2014, right? Again, that's the first observation. The second one is 2014. Okay, is it divisible by 3? Yes, but if you divide by 3, it is 2013 is divisible by 3, right? If you remember 2013 divided by 3, it is 671. So actually it's equal to 3. Actually, I need 4, right? I need 4. So the last two digits. So 2012, actually, 2012 divided by 4. So I can write it as 4 times, if you divide by 4, 2000, it is 512 it is 3, 503, 2012 plus 2, right? And I'm just going to use very simple property of indices or exponential expressions. Now here I have 3 to the power of 2014. I can write it as 3 to the power of 4 times 503 plus 2, right? Now I can write it as 3 to the power of 4 times 503 times 3 squared, right? I'm just using this property. A to the power of m plus n is equal to a to the power of m times a to the power of m. You know this, right, Musa? Do you know this property?
Yeah.
Very good. So now, okay, I'm just separating this. And also, I'm just going to use this one. A to the power of m times n is the same thing as a to the power of m and to the power of m. So now I can write this one as 3 to the power of 4 and to the power of 5 or 3 times 3 squared. Now from here, if I rewrite this, what we have here? Let me just continue here. Okay, 3 to the power of 4, we know that it is 81. And 81, I can write it as 5 times 16 plus 1, right? So this 81 is 5 times 16 plus 1 and to the power of 503 times 3 squared. Now again, this one a plus b to the power of n, I'm just going to use this for this expression, okay? This one. So what is it? I have here 5 times some number. I don't need it actually, the quotient. What number is it? But I'm sure that it's a whole number. And plus, I have here 1 to the power of 503, right? So 1 to the power of 503 is just equal to 1. But still, outside, I have 3 squared. That is 9. So now if I remove the brackets here, I have 5 times 9n, right? 9n. I just want it right like this, plus 9. Okay. So that means that if you just divide the whole number 3 to the power of 2014 by 5, the remainder will be 9, right? But 9 is greater than 5. Again, I can just write it as 5 times 9n plus 5 plus 4. Here the common factor is 5. I can take this out. That means that if you divide by 5, the remainder will be 4. So the answer is dot, dot, dot. The remainder is 4. Yes, Musa, Ibrahim, Daphne, if you did not understand any step, any parts, you may ask. Actually, in general, find the remainder when this is divided by this number. Find the remainder when this is divided by this number. Usually, we just use this idea. Okay, that's the idea, main idea. And if you understand this much, you can solve a lot of problems. Daphne, any questions?
No, teacher.
All right, Musa.
Like I didn't understand this step where like 5 multiplied by n plus 1. I didn't understand this step.
Actually, I try to explain that part mainly, But this one, Musa, if you look at the top, this thing, did you understand why am I writing like this?
Mm, mm, no.
Okay, just one more thing, and Musa, let me explain. Maybe later I'll give you more information, okay, about this. Oh, actually, in the previous slide, we have some space.
Okay.
Okay. Musa, I'm saying that here, last time I gave you example. One more time, let me just give you, just to explain this. Okay, here, if I have a plus b squared, if you expand this, what we have here, a squared plus 2ab plus b squared, okay? Now here, what is the common factor? Here we have a is a common factor. But inside I have a plus 2b, right? Hello? Musa, can you hear me?
Yeah, just my internet connection is slow.
I'm saying that Musa, this the first two terms, a squared plus 2ab. I'm saying that actually these terms always have a common factor of a. I just take this a out. So here we have a plus 2b, okay? Here I just have the sum of these whole numbers. I'm just labeling this number by n, okay? Because I don't need the actual their value, whatever it is. I don't need it. I'm not interested in this. So I can just write it as a times m. Now, if you substitute here, I can just write it as a times n plus b squared. All right. So actually, what should I understand from here? What part actually, how is it related to our problem? That means that if I have some number, let me just denote this by, what is it? Let's say m, that is a plus b squared. If you divide this number by a, the remainder is always b squared. That's what we should understand from this expression. Another example, how about if we have like a plus b cubed? Just one more example, okay? I can write it as a cubed plus 3a squared b plus 3ab squared, and here we have b cubed, okay? Now, actually, except for the last term, the remaining terms, they have a common factor of a. And let me just take this a out. And inside, I have the sum of some whole numbers. I'm not interested in this. That's why I'm just labeling whatever it is by n here. And what I have here, I have b cubed. Okay, in general, I'm saying that in general, it is true. I can prove that, but now you don't have to know that much proof, okay, because it takes time. Later, I can show the truth. In general, if you are given a plus b to the power of n, this a and b, these are whole numbers. N is also a whole number. I can always write it as a times some number. I'm not interested in this n, okay, some number. plus b to the power of n. Always I can just write it. Give me any thing, I can just write it as this. Okay. For example, again, 5 plus 2 cube, for example. I can always write it as 5 times some number plus 2 cube. Okay, the sum number is, it's a whole number. Okay. That's it, Musa. What I'm doing here is, okay, I'm just using this very simple idea
Yeah,
here, that idea.
thank you.
All right. Find the largest number of composite numbers less than 2014 that are relatively prime to one another. Okay. Find the largest number of composite numbers less than 2014 that are relatively prime to one another. An example, the highest common factor of any two of them is 1. Definitely, what do you understand from this question?
I don't understand anything out of that.
Find the largest number of composite numbers less than 2014 that are relatively prime to one another. The highest common factor of any two of them is 1. Okay, I think the answer is 2013, right? 2013, is it a prime number?
Yes, teacher, we looked at it like, I don't know, sometime.
We can check this. I think 2013 is a prime number, right? Yeah, we can check this actually, but still, is 2013 a prime number? Is 2013 a prime number?
No, it's not a prime number.
So it's not a prime number. So what is a small prime number less than 2014? Because find the largest number of composite numbers less than 2014 that are relatively prime to one another. An example, the highest common factor of any two of them is 1. Definitely. Also, I'm trying to understand. When I look at the question, I said, okay, that's an easy question, but now the idea doesn't come. Musa, what do you think? Any idea?
No, I could understand it.
Sometimes, the questions, it's okay, but let's try to understand this. I think it's not that's difficult. We know composite number, right? Composite number is a number which has more than 2 factors, like 4, 6, 9. They have more than 2 factors. We call them composite numbers. So the question is, find the largest number of composite numbers less than 2014. So how many composite numbers we have less than 2014 that are relatively prime to one another? With 2014, because if 2014, what is it? It is 2 times 107, right? And the 2 times, what is 107? 107 is, I think it's divisible by 19. 107 divided by 19, that's equal to 57. It is 19 times 57. Okay. So all the numbers, not okay. Okay, let's just have a skip for now. Okay, if I keep thinking, okay, even if I have the answer, it will not be so clear. We will discuss this soon. Okay, find the largest number of composite numbers. So we are looking how many composite numbers less than 2014. Okay, less than 2014 that are relatively prime to one another. Less than 2014. Okay, if you just pick any two composite numbers, okay, definitely should we understand this? Okay, I'm just wondering here the largest number, and we have composite numbers, and this composite numbers the largest one, is it? Because 2014 is equal to this, and how about 2013? 2013, the common factors are 3, 11, and 33, and 61, and 2013, right? So that means that 2013 and 2014, these two numbers are relatively prime because they don't have any common factor except one, right? 2, 19, 57, 57, what? 50, 53. This one is not 57, it's 53. Okay, good. All right, I got it now. So the answer is 2013. Why is it so? Okay, Musa definitely here is saying that find the largest number of composite numbers, okay, less than 2014 that are relatively prime to one another. So an example, the highest common factor of any two of them is 1. So that means that here 2014, if you just factor this, 2014 is equal to 2 times 19 times 53. And also I think we saw this in some different example. And how about 2013? That's the biggest one. I just checked this. Does it have any factor like 2, 90, 53? No. The factors of 2013, these are 3, 11, or 61. Actually, these are the factors of 2013. That means that 2 or 19 or 53, it is not a factor of 2013. So then 2013 and 2014, they are relatively prime to each other. Why? Because the highest common factor of these two numbers is only 1. So the largest of the composite numbers, 2013 is a composite number, but it is relatively prime with 2014. Okay. All right, that's it. We have one question. Musa, Defna, if you are there, I really wanted to give a try, okay? It may not be an easy question, but we have some idea about, for example, last time, if you remember, we did this kind of question, Musa, if you remember, 1 over x plus 1 over x is equal to, let's say, 5. And for example, x cubed plus 1 over x cubed is equal to what? Do you remember this question?
Yeah.
Okay, I'm just giving a hint. Okay, somehow you need to use this. Or maybe if I know x plus 1 over x equals 5, and also I can find the value of this one, right? X squared plus 1 over x squared, right? What is this? Okay, I'm just giving a hint. Using these ideas, we need to find the solutions of the following equations. Okay, how do you find the solution of these equations? Okay, now actually, that means that we have to solve this equation. Can you just think a little bit, all right? And after that, let's discuss together. Let me just give you 3 minutes. Defna, are you there?
No,
So where are you now? Doing shopping
I don't know. I wish.
or hiking or walking in the mountains?
Teacher, it's night.
Night?
Yes, I'm not that crazy to hike in this hour. I mean, yeah, I am a little bit like insane, but not that much. No.
Yeah, yeah, maybe in Baku it is night, right? Maybe you are doing hiking somewhere else, maybe in the USA or Brazil. No, it's not nighttime there.
Teacher, you think my parents would let me go? My immigrant parents would let me do something like that?
Who knows? Maybe you have some kind of special plane, so it just takes you there in a minute and brings it back in a minute again. So you can just, you're walking there and come back. Who knows?
Teacher, I saw something like that in one of my dreams back at the time. But I can only probably see it in my dreams, you know?
Yeah. Did you go to school today, Daphne?
No, we had online school.
So you enjoy online school, right?
No, I have
Also here,
always problems. I like physical school. I can talk to my friends and stuff. But it's very good. It's better, a lot better.
yeah, actually I don't like it, but all of us sudden here, some cases they found like 2 days ago now. They announced today, just now, I received an email. They closed all the schools again for 2 weeks. And I was going to give final exam next week to my students, and I should do everything online. What can we do? It's not a good news, but we have nothing to do with the situation. Now, starting from tomorrow, I need to do all my classes online, which means that I need to sit in front of laptop at least 5-6 hours every day. Anyway, let's see. Daphne, at least tell us an idea. What do you think? This question, how can we solve it? It's not that easy, but I'm just giving a hint. How can I have this kind of form from this equation?
Teacher, could you repeat it again? I didn't really hear you.
I mean, at the top, can you just write it, see that I wrote in green?
Yes.
Actually, this concept, this idea gives us some idea to solve this question, this equation. How can I apply this idea to solve this equation? That's my question. Musa, are you thinking?
I had no idea. The first I think I saw like I can multiply something, not multiply like factorization, but then I saw like it didn't give me anything.
Okay, let's do it together. At least you have some idea, at least in Sasmo, if you have this kind of question. This was a Sasmo question, but it's asked to secondary three students in 2013, but sometimes they may ask similar question to S2 students, okay? Sometimes some questions are, if you have noticed, very similar. I mean, S2, S3 questions are very similar. Some questions, not all. So now, if I substitute 0, right? 0 plus 0 minus 0 plus 0 plus 1 is not equal to 0. That means that 0 is equal to x equal 0 is not a solution. Okay, so I have no problem with this. All right. So now let me just divide both sides by x squared. Okay. Now if I divide both sides by x squared, what happens here? So here, let me just write this separately. Okay. This one I divide by x squared. Okay. And also this one by x squared. And this one by x squared. This one by x squared. Okay, Musa, is everything all right so far?
Yeah.
So now if I divide x to the power of 4, let me just draw a line because I need more space, a beautiful line. All right. Okay. So now if you divide x to the power of 4 by x squared, I have here x squared. X cubed is divided by x squared. Here I have x. And 10x squared is divided by x squared. Here I have just 10. X is divided by x squared. So I have here 1 over x. And 1 over x squared is just 1 over x squared. On the right hand side, 0 over x squared. I know that x is not equal to 0. So if you divide 0 by any non-zero number, that's equal to 0. Now let me just regroup this in this way. The first with the last term, all right? The second with the fourth term. Now what do we have here then? Here we have x squared plus 1 over x squared. And plus, here we have x plus 1 over x. And here we have minus 10 is equal to 0, right? And also, actually, if you remember this x squared plus 1 over x squared, this x squared plus 1 over x squared, what is it? It's just equal to x plus 1 over x squared minus 2, right? Because x squared, 2 times x times 1 over x is equal to 2. 2 minus 2 is just equal to 0. All right, using this one, let me now introduce new variable. And suppose that our t is equal to x plus 1 over x. Now, if you substitute into the equation, now I have something new here, right? So here, instead of x squared plus 1 over x squared, and this one is t, right? So I can just write here t squared minus 2 plus, and how about x plus 1 over x? It's just equal to t, and minus 10 is equal to 0. Or I have here this quadratic equation, x squared plus t minus 12 is equal to 0. And we have already studied this, how to solve this by factorization, right? And here we have 4 times minus 3, 4 plus minus 3. So I can factorize this as t plus 4 and t minus 3 is equal to 0. Now I have two possible answers. That means that number one is, what is it? T is equal to, what is t? T is x plus 1 over x. That's equal to 3. The second one is negative 4. I will solve this a bit later. If x plus 1 over x is equal to 3, what is x? So bring it to standard form, x squared, take x to the right hand side, after take to the left hand side, minus 3x plus 1 is equal to 0. All right. Now, if you solve this, what we have the answer here. How do I solve this by factorization? I cannot do that, but um, anyway, let me just keep this here. All right. Daphne, did you ever study solving quadratic equation using a formula?
What did you say, teacher? You lacked.
Solving quadratic equation by using a formula. Did you study it at school?
Which quadratical equations? Like,
So if you're given, for example, let me just write here, let's say ax squared plus bx plus c is equal to 0. How do you solve this?
yes,
First,
yes, it's that one.
discriminant
Oh,
is equal to b squared minus 4ac, right? And if it is greater than 0, then x1 equals minus b
discriminant.
plus minus square root of delta over 2a.
yes, yes, teacher. We used that. Didn't we use it here too, teacher? Am I mistaken?
Actually, here we studied only by factorization. The general form we didn't study yet.
I studied it after a little bit while after we did that like factorization, but then we used that formula too.
Good. I mean, if you study, very good. So here, how can I solve this? Discriminant equals 9 minus 4, that's equal to 5. So from here, x1 will be 3 plus square root of 5 over 2. And the second root will be 3 minus square root of 5 over 2. Okay. Now, how about the second case? Actually, t plus 4 is equal to 0. which means that t is equal to x plus 1 over x. That's equal to -4, or bring it to standard form, x squared plus 4x plus 1 is equal to 0. Now from here, discriminant equals 16 minus 4, that's equal to 12. So now another root, x3, that is minus 4 plus square root of 12 over 2, which is equal to by 2 minus 2 plus square root of 3. And x4, it will be just minus of this, -2 minus square root of 3. So altogether, actually, this equation has 4 solutions. That is number 1 and number 2 and number 3 and number 4. Why am I showing this here? Because last time we just saw the question, expressing this x plus 1 over x and x squared plus 1 over x squared and blah, blah, blah. Just using this idea, we have to solve this equation in case. Okay, Musa, did you understand a little bit?
Yeah, but at the first, like as if how to say, as the first like step, like where is x squared minus 3x plus 1 equals 0? Like, how did you get it?
How did I get what?
Like x squared minus 3x plus 1 equals 0.
I mean, which part are you talking about, Musa?
Like as a first step, t
This one?
equal x plus x equals 3. Yeah, like
Okay.
the second step.
So here we
How
have
did you
x
get
plus
it?
1 over x is equal to 3, right?
Yeah,
So multiply both sides by x. Here I have x squared
I
plus 1 is equal to 3x. And after that, take 3x to the left.
yeah, thank you.
Okay, good. All right. So that's it. Let's finish this and let's start something new. 2014. Just a minute. 14. Ibrahim, are you here?
Yes.
Okay, what happened? You have internet connection problem?
Yes, a bit.
Okay. Guys, let's continue them. Musa, Defna, Ibrahim, we are going to practice these questions. That is Sasmo from 2014 and S3. And once again, guys, if you practice these questions, similar questions, you get better intuition or idea about this type of questions. And as you practice more, you get actually better and better, and also questions get easier and easier. So when you look at the question, idea comes much faster. And the most important thing is having an idea how to solve the question. Idea means knowing the technique, right? How you can solve this question. And after that, that is a computational part. And that's why to have more ideas, we need to practice more different types of questions. All right. So now let's just answer quickly. Daphne, let's start with you. And this is a very easy question from 1 to 10 or 1 to 15 even. Questions are so easy. So we need to try to solve these questions in 1 minute. So solve for x
1 minute?
following equation. Yeah, 1 minute. Oh, 1 to 15. And after that, maybe for each question, you can spend like 4 or 5 minutes. But for this question, maybe you need to spend like 20 seconds. Yes, Musa, Defna, Ibrahim, what do you think? What is X and what is Y?
x equal minus, no, plus 7, y equal minus 8.
Yes, why is it so? Because here we have absolute value, right? Absolute value of something, any algebra expression or number is always greater than or equal to 0. And here we have square root of something, and also it's always greater than or equal to 0. And if you're adding two non-negative numbers, the sum is 0. And that is the only case if both are 0. Otherwise, two non-negative numbers, their sum is never equal to 0 if one of them at least is not equal to 0. So each one should be equal to 0. That means that x equals 7 and y is equal to -8. That's correct, Musa. And how about this question? We did this before, and let's do this one more time and together, and you'll try again question 3. Okay, so it says that arrange these numbers in ascending order. Ascending means from the smallest to the biggest, right? Descending means from the biggest to the smallest. So here, how do we compare this what is it, numbers with indices? Okay, so either we need to make their exponents the same or bases the same, right? Here, what are the bases here? 2, 3, and 4. How about the exponents? 18, 12, 6. From this 18, 12, 6, actually, they are all multiples of 6, right? So actually, I can just express this. For example, 2 to the power of 18. I can write it as 2 to the power of 3 times 6, right? And 2 cubed is 8, so I can write it as 8 to the power of 6. And how about 3 to the power of 12? I can write it as 3 to the power of 2 times 6. And here, 3 squared is 9, so it's 9 to the power of 6. And the last one is 4 to the power of 6. It's just 4 to the power of 6. Now all the powers are the same, right? Let me, which one is the biggest here? So 9 is the biggest. So it means that here I need to write here 3 to the power of 12. After that, which one is the second biggest? It's 8 to the power of 6. So that is greater than 2 to the power of 18. And the smallest one is 4 to the power of 16. So we have just arranged in ascending order. Okay, Ibrahim.
Yes.
How about these questions? We also did this. All right, let's do this together one more time, and maybe 5 and 6, let's say, you will try other numbers. Ibrahim, can you read question 3?
Um, Mersenne numbers are numbers from MP equals uh,
Mersenne numbers are numbers of the form. Ibrahim,
so my Wi-Fi is bad.
okay. Mersenne numbers are numbers of the form m sub p equals 2 to the power of p minus 1, right? Where p is a prime. You know what is prime number, which has exactly two different factors, like 2, 3, 4. I mean 2, 3, 5, 7, 11, blah, blah. For example, 3 equals 2 squared minus 1 is a Mersenne number. That's also a prime number. Find the smallest Mersenne number that is not a prime. Okay, find the smallest prime Mersenne number that is not a prime. So now just check this. Right here we have m. If is equal to the first prime number is 2, here we have 2 squared minus 1, that's equal to 3. It's a prime number, so actually it doesn't work for us here. Next prime number is 3. 2 cubed minus 1, that's equal to 8 minus 1, that's equal to 7. Also is a prime number. We are looking for a number which is not a prime. And how about next prime number is 5. 2 to the power of 5 minus 1, that is 31. Also it's a prime number. Next prime number is 7. It is 2 to the power of 7 minus 1. It is 128 minus 1, 127. And also that's a prime number. And how about m? Next number is 11. After 7 is 11, right? 2 to the power of 11 minus 1. 2 to the power of 11, what is it? 7, 8, 9, 10. Is it 1024? I think it is 1024 to the power of 11. It is 2048. And subtract 1, it is 2047. 127, is it a prime number? Yes, 127. Yes, Musa, what do you say about 2047? Is it a prime number?
I think yes, because like it's not like half of something. It's like let's say
Okay, 2047, it's not a prime number because usually, how do we know it's a prime number or not? I have to just divide this until, for example, the first prime number not divisible, the second and 5 and 7 until, for example, a number, let's say it is P, okay? This P should be less than or equal to square root of 2047, okay? So it's approximately is equal to what? Maybe 45 something. All right. So we had to just check actually dividing these numbers until 45, dividing by prime numbers. If this 2047 is not divisible until, by the prime numbers until 45, then it is a prime number. Okay. And maybe the proof we can discuss later if we have more time, but that is how we check it's a prime number or not. But actually, if you divide 2047, for example, what number by 23? Okay, I just check with 2, 3, 5, 7, 11, 13, 17. It doesn't work. 90 doesn't work. How about 23? And 204 divided by 23, it is 8, right? 8 times 3, 24. And 8 times 2, 16. With 2, it is 18. So subtract this, it is 0, it is 10, it is 2, 20. 207, and what is it? 8, 9. No, it is 7. Is it 9? Yes, 9, right? 9 times 3, it is 27. We have 2. 9 times with 18 with 2, it is 20. So the difference is 2. So that means that 2047, I can write it as 23 times 89, which means that 2047 is not a prime. So what is the smallest Mersenne number that is not a prime? The answer is 2047. Okay. Okay, Mr. Musa.
yeah, now I understand.
Good. Okay, Musa, how will you answer the next question? 4. What is the value of, find the exact value of 3 minus 1.9999? What is the answer?
Mm,
What is this 1.999 is equal to what?
is equal to. Let me
2,
remember this. Ah, yeah, two.
right? How do we change actually this recurring number into a fraction?
Mm. Yeah, it's to like one if one no like nine nine divided by nine like mm, I forgot this.
Okay, this one, to change this one, right? That means that here we have 1.999 dot dot. That means it's just like this, right? 1.9. This 9 is repeating. So to change this one, I need to write the whole number, right? 19, and minus, just subtract non-repeating part. It is 1 over how many actually it's repeating. That's just 1. So it is 9, right? So that's equal to 18 over 9. That's equal to 2, right? So it's like 0 point A, let's say B, C, for example. What is it? It is A, B, C minus A over BC, it is 9, 9. So anyway, that's equal to 2. So 3 minus 2, that's equal to 1. Okay. Daphne, are you still awake or already sleeping?
Teacher, I am awake, but my brain is sleeping.
Your brain never sleeps, you know that? How come brain sleep? Brain never sleeps.
Brains, teacher, they can not sleep, yes. No, it's the
Yes.
heart that can't sleep, not the
Heart?
brain. Brain is a brain is a muscle. So
What?
is heart.
Brain is a muscle?
Yes.
No, brain is not a muscle.
It is a muscle, teacher. It
I'm not.
grows just like a muscle. It has like the physical abilities of a muscle, but like when it comes to all the other stuff, yes, it is sort of like a brain, you know. But when it comes to a heart, for example, heart is a muscle and also an organ. So it grows, but like you can't tire it. Don't tire it too much. That's what it's taught to do.
Yeah. And actually, I think your body, maybe, I don't know, your spirit or soul is tired. I think brain never gets tired. I don't know. Maybe brain also gets tired. I don't know. But
Yeah.
sometimes our brain
If your
stops
brain
thinking.
gets tired,
Is it
you
because
have
of
to
our
die.
physical body
You'll
or,
die.
huh?
If your brain or like your heart gets tired, then you'll die.
Yeah. Yeah, I mean, for example, let's say in the early morning, teaching the
My brain
first,
cells are sleeping.
huh?
My brain cells are sleeping. Like
You think so, but brain never sleeps. Okay. Daphne, how about this? You saw this question for us. First, can you read it? First, let's try to understand what they mean, and after that, we'll discuss this.
the
Can you read the
Fibonacci
question?
numbers are 1, 1, 2, 3, 5, 8, 13, where each term of after the second term is obtained by adding the previous two terms. How many of those first 2014 Fibonacci numbers are odd? Wow. We're supposed to find that?
Yes.
How?
We just keep writing these numbers, and if you just write 2014, and most probably, if they ask the similar question in Sasmo 2021, instead of this 2014, I will just actually write 2021. Okay. Number one, we asked the two questions. Number one is when it is 2014, right? If you just write 1, 1, 2, 3, 5, 8, 13, 21, 34, continue. What we have to hear is how many of the first 2014 Fibonacci numbers are odd. Just we need to find here the number of odd numbers. So here, if you look at these numbers, the first one is odd, odd, even. And 3 is odd number, even. Again, it is odd number, even. If I just group in 3, right, 2 of these 3 numbers are odd, right? So now the question is, until 2014, how many 3's do we have, right? And as I see here, 2014 is not divisible by 3, but 2014, I can write it as 2013 plus 1, which is equal to 2013. If you divide by 3, it is 20 divided by 3, it is 6, 21 by 3, 7, 3 by 1, it is, by 3, it is 1, is equal to 1. That means that until 2014, we have 671 groups of 3's, right? And plus 1. So that means if I just continue here, this will be again odd, odd, and even, right? And after that, this odd. So this one is 2014, right? So then the question is, how many of the first 2014 Fibonacci numbers are odd? To answer this question, then 671 groups of three, and in each group we have two odd numbers, right? And plus, and also actually right after that we have one more odd number, so that is plus one, which is equal to 2 times 1 is 2, plus 1 it is 3. 2 times 7 is 14. We have 1. 2 times 6 is 12. With 1 it is 3. So we have 1,343 odd numbers until 2014 term inclusive. Okay. Musa, Defna, Ibrahim, any questions?
No, all of them is clear.
No, teacher.
Good,
Even my
guys.
question marks, they're asleep.
Let's solve the last question, and after that I will finish the class. Okay. And
Teacher,
just
what does
definitely tell us the
integers
idea.
mean?
How do we solve this question? We did a similar one, right, Musa? Do you remember?
Yeah.
How do you solve this question? As you see
First
here,
of all,
remember, on the right-hand side, we have 43, right? And it is a prime number. The only way we can write prime number is like maybe 1 times 43 or 43 times 1. We don't have any other options for this because we are talking about positive integers. And x squared minus 9y squared. And if I factorize this, it is x minus 3y times x plus 3y, right, is equal to 43. And the difference of two numbers, the sum of two numbers. If x, y are positive integers, the difference of two numbers is always less than the sum of these two numbers, if they are positive integers. That means that this x minus 3y then must be equal to the smaller factor, that's equal to 1, and x plus 3y must be equal to 43. So now if we just add them together, 44, what is x? It is 22. If x is 22, it is 21. What is y? Y is equal to 7. So find the values of x and y, which satisfy the equation. The values of x and y are 22 and 7. Okay, Musa, Defna, Ibrahim, any questions?
no.
Okay, guys, Musa, Ibrahim, Daphne, again, I'm actually pronouncing your names a lot. If you have a time, have a look. Okay, if you come with ideas to the class, actually we'll go much faster. Otherwise, I mean, we're also going fine, but there are a lot of things to do. Okay, so that much is enough for today. Have some good rest. Usually Monday is a little bit hard day because it's the first day of the week. It's fine. And I will drop these questions again in the WhatsApp group maybe. I think, Musa, did I already share these questions with you or not yet?
No,
Okay,
only
then
some written.
okay, I will just drop this, okay? And if you have a time, try to practice some questions. And if you come with ideas, we can go much faster. Okay, Defna, Musa, Ibrahim, have a good night. I will meet you on Wednesday, okay? See you on
Okay.
Wednesday.
Okay, bye.
Okay, teacher,
Bye-bye.
Goodbye.
bye.
Thank you. Bye-bye.